Hi, my name is Muhammad Zaman Hisham. I'm from J4EM103.
Hai, Assalamualaikum. My name is Muhammad Ariadi bin Harun Nizam.
Assalamualaikum. My name is Muhammad Yunus Dinen bin Nazaruddin and I'm from class J4EM103E.
So for discussion, the first question is compare the result of this test between the experiment and the reference value of modulus of rigidity, Torsion ratio, shear stress and shear strain. Comment on any difference and possible source of error. Okay, so the reason the result is different is because the value of this experiment is exposed to the external factors. This include thermal expansion and machine inaccuracy. For the reference value is based on the experiment and external force and neglected to achieve the exact value. That's the reason the experiment value and the reference value is different. So for the second question, describe the behavior of this material as it responds to increasing applied torque. So the angle of twist will also increase. This causes the material to twist more because there is more shear stress, and as the shear stress increases, the shear strength will also increase. This is because the shear stress is directly proportional to shear strength. So for the third question, is the Hooke's law for shearing stress and strain valid? Explain. So the answer is yes. This is because the Hooke's law can be applied to any material if it is in the elastic limit, and if the material is already over the elastic limit, then the Hooke's law is no longer valid. For the fourth question, describe the appearance of the fracture surface of the tested specimen and discuss the mode of failure, ductile failure or brittle failure under torsion. So steel is a brittle material. Therefore, the fracture surface is smooth and show the steel experience brittle failure. As for brass, it's a ductile material, so the fracture surface for brass is dull and shows that the brass is experience ductile failure. So for the last question of discussion, which should be able to resist more torque, a solid bar or hollow bar of the same material and cross-sectional area? Explain. So a hollow bar can withstand more torque compared to the solid bar. This is because a hollow bar has more diameter than a solid bar. This will help to stand more torque when it is applied. Besides that, a hollow bar has more polar moment of inertia. Therefore, the hollow bar is able to resist more torque compared to solid bar.
The experimental value is different from reference value because of systematic errors that occur, such as machine inaccuracy and sensitivity. As the torque increase, the angle of twist, shear stress, and shear strength will increase. Yes, it is because it can be applied to materials within the elastic limit, and it will be no longer valid if the material exceeds the limit. Steel will undergo brittle fracture due to the increasing torque, while brass will experience ductile fracture as it reaches limit. Hollow bar. It is because hollow bar can withstand more torque due to its diameter and high polar moment of inertia.
Number 1. The value of the experimental are different. It is because the systematic errors, for example machine, in accuracy and sensitivity. Number 2. From the experiment, we can see the material is responding to increasing applied torque. The sample will break into two parts under the torsion. So we can see the behavior of material are divided into two, which are ductile and brittle. Brittle materials do not neck down significantly. Instead, they fail sharply and abruptly at the maximum force because brittle materials do not exhibit much plasticity. So number 3, the Hooke's law for shearing stress and strain is not valid. It is because Hooke's law is only valid up to proportional limit of a material. Beyond this limit, Hooke's law not longer applies and the material remains deformed even when the stress is removed beyond the elastic limit. Number 4, steel is ductile and dull and fibrous, and for brass it is brittle and smooth. And last but not least, number 5, a hollow bar of the some material and cross-sectional area is able to resist more torque. It is because the diameter of hollow shaft is more than the solid shaft, then that can require more space.
So to conclude from this experiment, I have learned to determine the modulus of rigidity, maximum shearing stress, maximum shearing strain, and Poisson ratio for the tested specimen. I also learned that the torsion test is a test that twists a material until the material fails in torsion. Other than that, I also learned that all specimen has different shear stress and shear strain, and it is important to know this before using a certain specimen or item before we start a project. Besides that, this shear stress and shear strain is different from normal stress and normal strain which is used in tensile test. That's all, thank you.
As the conclusion, the modulus of rigidity, maximum shear stress, and maximum shearing strain, and Poisson ratio for the steel and brass was obtained. The linearly elastic behavior of the tested specimen under torsion and the relationship between torsion load, angle of twist, and the shear modulus was achieved.
For the conclusion, the objective of this experiment was achieved. It is because we have determined the modulus of rigidity, maximum shearing stress, maximum shearing strain, and Poisson ratio for the test specimen, and study the linearly elastic behavior of the test specimen under torsion.